So how exactly do you deploy your local AI agent into production? Well, for this, you're going to make sure you have the following components set up. The theory that you're going to learn in this video is actually applicable to any cloud provider, any platform of your choice, but I'm going to be going with Google's Gemini Enterprise Agent platform because I think it's the most easiest and most comprehensive, especially for enterprises and fast-growing companies. So let's imagine this is your local AI agent that you just built on your local machine, and this app is about a log triage, meaning as soon as you give it these logs, or any logs pretty much, it should be able to categorize them and prioritize them based on severity, so that the developer can later look into it and make its own conclusion. Now, what we have here is basic tool call, for example, to list the files, log the files, and also we have an access to a database to do a vector search. But this is not enough to go to production. What we need on production instead is kind of a runtime where this agent is going to be living. And the Gemini Enterprise Agent platform, or pretty much any platform of your choice, most likely will offer something like this, where you can deploy and scale your agent with a managed runtime. And my personal tip, if you do go with agent platform, you gotta make sure you use this agent CLI. It's gonna facilitate everything because it has some pre-baked skills into it that are gonna help with scaffolding, developing and pretty much deploying it on the cloud. So the agent CLI does come with its predefined lifecycle, which consists of 8 phases, such as spec, scaffold, build, deploy, publish, and so on. What I'm trying to say is that as soon as you install this CLI, it's going to give you these following skills, such as Google Agent CLI scaffold, eval, deploy, publish, and so on. Now, depending on what coding agent you're using, in my case, I'm going to be using Claude Code. I can go into my terminal, so I can turn on Claude Code like this. And as soon as I do skills, I'm going to see that I do have some skills, but they're locked by a plugin, and I have some that are on. And these are belonging to the agent CLI. Now, since I already have my application here, as you can see, the agent does have some simple code. What I want to do is actually just go and deploy this on the agent runtime. For this, I'm going to go here, the lifecycle, and to the deployment like this. And of course, I can either run this command, or I can simply tell Claude, hey, please deploy it on agent platform. And as soon as I do this, it's actually gonna go ahead and use one of the skills that were defined in agent CLI. Now my deployment should be done. So if I go to agents, deployments, I should be able to see my application already listed here. And I'm gonna see a nice dashboard here. Well, now that we have our runtime and we have our agent actually deployed already, we are missing something. And in this case, this will be our own identity for the agent. So let's talk about this. Whenever you are using a browser and you reach out to some kind of a web server, website, or an AI agent hosted somewhere, you're going to be doing a TLS handshake to verify that, hey, this is me and I am who I'm saying I am, right? And with this, you're going to be sending a JWT token that the web server already knows and can verify that, yeah, it is actually you. You're correct. Now, when agents talk to each other, or let's say there's an AI agent which is not in your cloud system and it's something external, using an API key, just like you would use an API key for authenticating yourself, is kind of a bad idea. Instead, every agent within the cloud should have its own ID. And this is called a SPIFFE ID. And SPIFFE is basically nothing new. It's used a lot within the cloud native environment, in especially Kubernetes, where microservices should be able to kind of have an identity while talking to each other. I will leave this page for you to go and watch this video. And if you want to dive deep, you can do that. But SPIFFE basically means Secure Production Identity Framework for everyone. And the cool thing is the agent platform automatically gives you an identity upon deployment. So this will be our identity here, as you can see. Okay, now how about memory? How do we make sure that our memory is persisted not only across sessions, but also across deployments, or even if our agent goes offline? Now for this, we're going to be using a memory bank. A memory bank is going to be working like this. So for example, if I go into my agent.py, you're going to see this preload memory tool. And this is coming from Google ADK. ADK stands for Agent Development Kit, and it's a framework for easily building and deploying your AI agents. It's pretty simple to use. It's also from Google, so it's gaining a lot of popularity, I feel like, in the recent times. And by running this method here, it's going to automatically realize whether you're developing this locally, then it's going to have a session memory for your local agent, or if it's deployed in the cloud, it's automatically going to be hooked into the memory bank. And what is exactly the memory bank? So if I go to this tab here called memory bank, you're going to see that it's wired with one of my agents, and it pretty much shows some stats on latency and so on, and of course some entries for the memory. Now, how is it different than saving all of these data, for example, in a relational database? Now you see the memory bank is not just a normal database. First of all, we have a shared memory that's not going to be persistent. So instead we're using a memory bank, and memory bank has this extra capabilities such as append event, it can generate memories, it can consolidate, and all of this is going to be happening automatically as your agents are communicating with each other. So the memory bank is kind of listening to all the interactions between the user or the agents themselves, and it's going to automatically retrieve, consolidate the memories that it needs based on natural language memories. And of course, you can also define your structured profiles, meaning you can tell the memory bank how exactly you want your structure to look like. So it's kind of an advanced way of saving things. With that said, let's talk about observability. What happens when the user interacts with the agent? How can we see how good the quality is? Also, how can we see how much money are we actually spending through all of these interactions, right? Also, can we see the speed at which the user gets the response back? Well, of course we can. So as you would expect, when I click on my application, I'm going to have some crucial information automatically showing to me. But sometimes you really want to dig deep into your agent's functioning, because sometimes you have really weird errors like this one, and you're not sure how to overcome this or how to make sure that this doesn't happen in production anymore. Well, for this, you have the choice to go into the Logs Explorer and actually look into different categories, severity, and so on, and even ask Gemini to investigate it for you. Apart from this, you can also go to the usage tab where you're going to see how many tokens are used, your CPU utilization, the memory utilization. You have traces, you have revisions, and of course evaluations, because I think this is the most important for product teams, because you want to see how your quality response, how safe it is, and how the tool usage quality is, and of course how much your agent actually does hallucinate. Now you might be wondering, what are these green tiles? And as you can see, these are in fact agent gateways. We have ingress and we have egress for the outgoing traffic. Why do we need those? Well, you want to make sure that all the incoming traffic is rate limited, it's authenticated and authorized, and the agent gateways help us to do exactly this. So every time the request goes outside into the world, we want to make sure that it's compliant with our policies, and the same when they interact with our tools. Now, on top of this, it was not on my graph, but we have a model armor. It basically protects our AI agents from prompt responses and agent interactions, and it lives within our environment. So let's say our agent does interact with an AI agent that's outside. How do we make sure that we are not exposing any sensitive information? How do we make sure that these requests or the information that's going to come back is secure? Now, Model Armor is going to do exactly that. Last but not least, we have Agent Registry, where all of our agents that are available to us can be registered here, so that every time we interact with it, it can reroute the request into the right agent. And it is available under this tab. Here's the list of agents and MCP servers, as well as endpoint and skills available to us. If you liked the video, make sure to subscribe and go check out the agent platform. The link is going to be in the description below. Don't forget to do that. And I'm going to see you in the next one. Goodbye.